Hi, so this is our CrowdCheer sprint video for the entire quarter, just kind of an overview of what we've done this quarter. Um, the motivation of our project is it revolves around the experience of runners at races, specifically longer races like half marathons and marathons. And something we noticed was that spectators at spectators at these kind of races, they tend to congregate at the beginning and end of a race, and not necessarily during the pain points where runners need them most. And those pain points, they tend to happen during like the 60% mark during the race and the 70% mark, or 75%. So, like, around three-fourths of the way through the race, runners really find themselves struggling, but there are no spectators around those portions of the races because it might not be convenient for them to be there, and then runners end up struggling during those points, and then designing race strategies to really self motivate themselves and conserve energy so that they can power through those portions. So, if we were to somehow figure out a way to get people to move to those areas or support runners where they actually need it, they might not necessarily need to design their race strategies that way and could support themselves and maybe even perform better at these kind of races. So, um, yeah, that brings us to the research questions that we want to ask.
Yeah, so for the research questions that we have with CrowdCheer is that how might we crowdsource the power of ad hoc crowd, so in this case, the spectators of the races, to provide motivational support for the runners throughout the race? And then, so more specifically, how can we develop a system that coordinates real-time physical crowdsourcing tasks? So in this case specifically, it's coordinating the spectators to find the runners at the exact time. And so, also, how might we build upon existing behavioral patterns of ad hoc crowds to design a task that naturally motivates participation? So, currently, one of the things that we're running into is how do we make sure that spectators at marathons, are actually willing and comfortable cheering for strangers, even or their friends at a race, and how can we get them? How can we make this like an app that they would want to use when they're a part of a crowd?
Mm-hmm. So going off of those two questions, we've been focusing on that first sub question for a while now, and that's how could we develop a system that would support this kind of interaction? And we've kind of come up with a framework that we think will work well, just based on um, the type of information that we need to give the spectators so that they could actually identify the runner at the right time. So, yeah, just a quick overview. CrowdCheer, our app, will monitor the event. So in this case, that means that it's just kind of keeping track of location information for both the runner and the cheer at high, just like fine grained accuracy, so that we are aware of their motions throughout the race. And then we are looking for some sort of a status change which will trigger the system. And then in this case, the status change is going to be as a spectator, I'm standing at some point during the race, and a runner is going to be running past me. So the status changes when does that runner enter my sort of like cheering zone around me, and when do I need to really care about the runner. So once we set off that trigger, the system then identifies what task we're supposed to be assigning the crowd worker. And that right now we're just letting the crowd worker sort of pick and choose who they're going to cheer for, but eventually we want to think about how we can cleverly assign um, different runners to spectators or provide them a subset of runners that they might be more interested in cheering. So, for example, if they share an interest in like a university or something like that, or they're fans of the same sports team, um, we would give them those specific runners to cheer from. So once we kind of have an idea of what tasks to give the crowd workers, we notify them that the task is approaching temporally, meaning that, so in this case, the runner is approaching within the next couple of minutes or seconds. Um, and then the app contextualizes the task. So spectators can't necessarily cheer without knowing a little bit about the runner. So we provide them with that context, and we need to provide it early enough so that the spectator has enough time to really process that information. So the kind of information we're giving is like a picture of the runner, distance information, and a map so that you can kind of track the runner as they approach you. So once we contextualize the task, the crowd worker can then deliver on whatever the task is. So in this case, they're delivering motivational support, and then that motivational support is received by the runner, and then ideally that runner would react positively to that support.
Cool. And so for this quarter, for tech-wise for CrowdCheer, we really focused on making our code more modularized and cleaner. By doing this, we moved to Swift, and what we did was following the protocol-oriented programming design patterns that is popularized with Apple. So, should I scroll down?
Oh, yeah.
If we go down here, you can kind of see like how we are structuring our code now. More specifically, following the view controller, and view model. That's like found commonly in iOS Swift apps today. So we have this so we can easily swap things out as things come up. If we find that we're not providing the right context for cheers to find the runners, or if this isn't the type of information we should even be recording for the runner, all of this is a lot easier given our new architecture. And now we'll actually give you a demo so you can see how this is working as of right now.
Mm-hmm.
And then I'm going to also pull up parse, which we're using for our database.
So, thinking back on the different phases of the interaction that we were talking about, that first one that we were thinking about was monitoring. So that's what the app, we've kind of like modularized out that portion of it using our new architecture. So we'll just kind of walk through the code for that. But for, let's see. Okay, so just to give you like a quick overview, before the view controller for accomplishing tracking looked like this. There was a lot of code happening on the view controller, and all of the functionality was happening on the view controller, which isn't ideal. That's not something that you want when, especially for managing your project and just being able to debug easily. So
now we have it broken down. So we have tracking protocols, and this is for both the cheerer and the runner, since we'll be tracking their location for both of them. The only difference is that for the runner, we also want to keep track of their pace, so we can actually deliver motivation when their pace drops. So as you can see here on the screen as we're scrolling down, the runner tracker and the cheerer tracker is a little different.
Most of the functionality is about the same, but there are certain things for the runner tracker that we need to track that we don't need to for the runner. So, for example, we need to care about pace for a runner, but for a spectator or cheerer, we don't really need to care about that, so we're not really using that. And then they also just stored at different locations on parse. So if we refresh parse over here, we see that we have a stream of data coming back. And the view controller, so all of the functionality having to do with like the calculation and handling the location, saving to parse happens in there. And the view controller is just a really simple couple of lines where we set off a timer, and that timer just calls our functions, and then which handles the tracking of the user and then actually saving it to parse. Cool. So we also completed a short study this quarter, which it was definitely a small study. We had, like you see below here, there were only about 6 participants, but the idea was to we wanted to be able to just simulate a race crowd so that we could understand whether the primers that we had developed before with the picture and the map and then the distance information, if that would actually help identify the runner.
Sorry. Like in our previous sprint video, we did this by setting up a cheer and a runner during passing periods in front of Ford, which is a building at Northwestern between when classes were changing, just trying to simulate that crowd situation. Due to the week before finals, there wasn't that big of a crowd when there were people walking to begin with, and it was just harder to get participants for that week.
Right. So through the findings, we definitely want to do a bigger study because we can't say that this is conclusive, but it was generally positive. Out of the 6 participants, 60% of them were able to successfully use the information that we gave in the app to identify a stranger as they approached, which was encouraging for sure. But like we said, we need to conduct a more conclusive study. Some of the limitations for the study, for the post-survey, not many people responded, which might have been a result of it being finals week and a lot of people were occupied. It was definitely a smaller study. The crowds weren't very dense, so like a typical passing period would have massive crowds out walking around of just different students and whatnot, but again, because it was finals week, there were maybe at most 5 people out at once, so it wasn't as dense as you might see at a big race. And then also the pace of the walking participants was a lot slower than a pace of a runner that you might see. So that affected the way that our app was built. It was built to really time and give information in time based on a runner approaching, which is a lot faster. So we give more of cushion room and cushion time. But that was ended up being excessive because walking participants are a lot slower. So that led to a less comfortable interaction.
Cool. And then for next steps for next quarter and GTR, we hope to design, build, and test ways to motivate crowd participation based on the existing behavior that we see or that we've seen so far and we've read about. And then we also want to continue with our architecture design and code cleanup and move more of our Objective-C code into Swift. And then finally, we want to test and modify our interaction design. So basically hold much larger studies of what the smaller study we did this past quarter.
Yep. And that was our quarter. Thanks.